What's going on here today?
Well, okay, today is our first official competition. So we brought our robot and we're gonna compete and try to get as many points as we can. Yep. And if we get enough points here and in our second qualifying competition, we can qualify to go to the district championships. And if we do well enough there, we can go to Worlds. So that'll be very exciting.
You can pass the mic on. So, what do you do? What are the robots doing?
So, as you can see, this is the field. So, each robot picks up these orange, discs. They look like frisbees, but with, a hole in the middle, sort of like a extended donut. And we pick those up and we shoot them in various different places. So there's a place called, the speaker, which is sort of, higher up, and you have to shoot at an angle. There's a place called the amp, which is more, vertical and sort of like a slot you can put it in. And then robots can also hang on chains on what's called the stage. And, yeah, that's about it. To get points.
These are not robots destroying each other.
No. It's a little bit different from BattleBots.
Yeah.
So you're the founder. How long have you guys doing this?
So we founded our team in 2020 during COVID, and we founded it completely independently outside of the school so we could work on our own time together, and it was really hard with all the code restrictions, and we made it to only one competition that year, and since then we've grown our team from only 12 to 40 members. We make one robot every year. It's a different game every year. Last year we had to pick up cones and cubes and we had a whole different robot.
So they tell you what's going to happen that year, and you have to figure out a robot that will do that best?
Yeah. So they announced the game on January 5th. Okay, in the first week of January, they announced the game, and you have until that announcement date, until your first competition, to build the robot. Last year, that was about 12 weeks for us, and this year we challenged ourselves to finish the robot before our first competition, so we'd have more time for testing and fine-tuning everything. So we gave ourselves only 6 weeks this year to build our robot. So we build our robot out of a varied assortment of off-the-shelf components and components that we manufactured ourselves. We split our robot building process into 3 sub-teams. There's the mechanical, electrical, and software sub-teams. I'm in charge of the mechanical, so that's what I know best. In terms of mechanical, we designed the robot on a computer, fully on our own. We have an entire design ready before we build anything, and then we will assemble it with a big team of people. Some of the things we assemble, we use what's called a CNC machine or a CNC milling machine, and with that we can create our own custom parts out of aluminum or polycarbonate, and we can make complex shapes that fit our needs.
So, well, this is a big part of the team. It's obviously building the robot, but that's only 3-4 months out of the year. We're working year-round to do things. For example, from September to January, we are recruiting new members, and then we have this thing called the preseason, where we teach them all the skills that they need to be able to build the robot once the game is announced. So we have things like workshops, projects, where all the new members learn all the things for all the sub-teams about how to make the best robot that they can. And we also do a lot of outreach events. So for example, over the past summer, we did these summer workshops where we basically had kids come in. They were 4th through 6th graders for the most part. And we had them, it was basically like a STEM summer camp where we taught them about robotics. We had them build their own robots, and they got to play in these kind of these, based on FRC style matches, but a smaller scale with their own robots, which is really cool.
So when we founded our team in 2020, we were founded by 12 members of Wellesley High School, founded by 6 members. And they were a part of a previous team, robotics team, at the high school, and they felt that their voices weren't being heard because of their gender at this robotics team. So they decided to found a new robotics team based on values of inclusion and equity for all. And we decided to compete in the first robotics competition because it's one of the most famous and popular robotics competitions around the world. So we started I started in freshman year. So did Stephanie?
Yeah, I also started in freshman year. So this robotics team is mostly for 9th through 12th graders, so high schoolers at Wellesley High School. But we also run FLL teams at the middle school for middle school students, where it's kind of it's run by the same organization first, but it's a little simpler, smaller scale, and the robots are made out of Legos. But it's still really cool. You still get that STEM experience and that leadership experience, even in middle school.
Do you guys like start with like you buy a kit online and then you build up to designing it yourself, or how does that work?
Yeah, so our first year, our robot, we bought a kit online that was just a drivetrain, so it was just some wheels that could drive around, and we assembled that, and then we built some stuff on top of it, some really simple shooter mechanism, and from that we've evolved. Our second year, we bought the same drivetrain, but we built a more complicated system on top of it and changed out those components. Our third year, we started with Swerve Drive, which is everything in the robot was things that we built ourselves. We still had some off-the-shelf components, but the drivetrain was a lot more complicated, and yeah, it was we did more of it. I don't know how to explain it better. Yeah.
And Swerve Drive is much more difficult, or much more complex, because it allows our normal drivetrain you can only go forward, backwards, and turn side to side. But with Swerve, yeah. Yes. Okay, it didn't.
Why don't you grab the mic? Grab the mic. Let's pass it up.
So our team is down here. Right now, the robot is moving fully autonomously. There's no driver controlling it, and that buzzer means that now the drivers are going to control it. So we're trying to pick up these cones, these orange discs off the ground, and shoot them into the target on the. I guess we have red bumpers on, but we're on the Blue Alliance. This is a practice match, so we can do that. And yeah, so you see we're about to shoot into the. That's called the speaker. And there we go. So we just shot. Now we're going to drive across the field over to this area and try to pick up another orange disc.
It reminds me a little bit of bumper cars. Are you allowed to bump into the other?
Oh yeah, there's a whole strategy around it. There's a whole strategy called defense, where if your robot isn't capable, or like maybe your robot broke or something, and you're not able to shoot or play the game, if you're still able to drive, you can get in the way of the opposing robots, and you can make them less effective. And it's a really fun strategy called defense. You're allowed to bump into other robots, and you're even allowed to pin them against the wall for 5 seconds.
I imagine everybody wants to be the driver.
Yeah. So you can see our drivers back there. There's a blue 8567 on the left side, and our 3 drivers are wearing purple. It's kind of hard to see them from here. But yeah. And you can see there's 50 seconds left. The score is 22-35. And at the end of the game, when there's even less seconds left, close to 15 to 20 seconds, the robots are going to start climbing up onto those chains. Yeah. Our robot isn't able to climb at this competition, but we're planning to get that working by next one. Yeah.
So they tell you how it's going to go, but how do you figure out how to design it?
That's all up to us. So I did most of the actual CADing this year. For the first week after the game is announced, we just do brainstorming. We just think of as many ideas as possible. We think them through, and we decide the pros and cons of every idea, and then we implement it. The first thing we do is we create a prioritized list of what we want to do, like what we definitely want to do, what we could do, and what we might want to do. Like, we definitely want to be able to shoot. We definitely want to be able to pick up notes off the ground. We might want to climb, and we haven't climbed yet, but we are going to plan to do that later.
100% of our current seniors and our alumni are going into STEM majors. So that could be a lot of them are going to engineering. Some people are doing architecture or some other type of science. But pretty much all of our current graduating seniors and all of our already graduated alumni, all of them are going into some type of STEM field, which is very amazing to see. And I know that for sure, at least I've had multiple people on the team tell me that the reason that they are going into engineering, for example, is because of their experience on this team. For example, do you want to talk about yourself?
Yeah. So I am since we founded the team, I've been a mechanical lead, and I focus on the CAD, the designing the robot and assembling it, but more so the designing part, because assembling it is easier to do. So every single year I've been doing that and been getting better at, and that's what I want to do for a living going forward. I'm majoring in mechanical engineering next year.
So what are the kind of jobs you get with if you're getting into robotics?
Well, lots of, like, for example, phones are not built by people anymore. This phone and that phone is built pretty much entirely by robots. So being able to design that kind of thing. And for me specifically, outside of robotics, everything needs to be designed by a computer, on a computer at some point. So that's something that I'd be interested in.
What about robots taking our jobs?
They took our jobs! They took your jobs!
They took your job!
They took your job!
I'm so down for that.
Well, I mean, even if robots take our jobs, you need someone to design those robots, so.
What do you guys think about AI?
I mean, it's kind of early to tell what's going to happen with AI, but I'm here for it. I think it's really interesting, all the things that we can do with AI, and then, like, our world is changing, and I'm excited to see what the future holds.
What about robots taking over?
Well, as I was saying, like, that still creates a lot more jobs in the, like, STEM field, which is why we have been pushing so hard for, like, more people to get into STEM, because that's a really sustainable path in the future. For example, another thing that we have been working on is advocating for a bill. I think it's H577/S360 in the, like, Massachusetts state legislature. We're trying to get a bill passed that will help provide funding to people, especially underserved communities, to start their own robotics teams or other types of, like, STEM extracurriculars. And a big thing, that reason we're pushing for that is because of the way that the workforce is transforming as time goes on and going more towards STEM. And we want to make sure that Massachusetts still has that strong workforce by making sure that more and more people get into STEM.
But what about the killer robots? Are you guys going to be building Terminators in the future?
I don't plan on building any Terminators in the future. I think that robots can definitely be used for good, as long as, you know, we're making sure we have, like, regulations on them.
Okay. So you're not too worried about it?
I'm not.
No, I think robots in the future are going to be used for automating things, like my phone, and eventually for more things than phones that need to be automated by robots, like things that could be built by humans. I can't wait for automation to be more.
Robots taking drudgery out of our life.
Yeah, especially like physical and dangerous jobs. Like, robots are really good. Like, for example, one thing the robots have done for a while is, like, defusing bombs, because you don't want a human doing that, and it's way safer for a robot to do that. And we could have robots do all sorts of things like that. And, like, all those huge factories, like, that we get things made in China, like, we can have them made here by robots.
So over here is our dashboard. This is the control for the robot. This is what we actually are seeing in a match. Over here is how we connect and communicate with the robot. And over here is our dashboard of things. So you can see on the left, if you come close, we can see whether or not we have what we call a note, the orange rings, collected or not. If this is red, then we do not have one. But if it's green, we have one. And you can see a camera. We have a camera on the robot, so you can actually see what's going on in front of you. When we're going very far off into on the field, you can't really see the robot that well, so having that camera is really good. So, Alexis, do you want to maybe do the driving? And
Yeah,
I can do, I think this is one. Yeah. Let me just quickly check, actually. Yeah, you can hold the button so that, yeah, okay. So, we can show you here just a few quick movements of the robot. If you look over on the robot, we can turn around, we can move in any direction at any speed we want. Hold the buttons, yeah. And we can also actually move and turn at the same time, Alexis, if you want to show them that. So you have this very strong control. In the pits, you're required to be wired to the robot. In a match, you actually have wireless communication, but for safety reasons and having not that much Wi-Fi traffic, you can keep it on. But so now actually we can show you how we can move the arm. So if you have it in profile, you can look at actually the arm moving. That's good. So I can lift the arm up and down manually, and I can also say, okay, I want this to go to an upright position, and it automatically sets us to that upright position, and it holds that position. If you try to push it around, you find you wouldn't be able to. So now if we go down to the intaking position, we can pick up a note by running the intake. And so then we go up to there, and if you look on my screen now, over here, now that we have a note, the sensor has actually detected it. So now we're flashing green, and it turned off the intake. So now, if we go to the taxi position, it would be like this. And if we want to shoot in the amp, which is the lower amount, then we go to that position, and then we can simply turn on the flywheels, and then shoot. Well, yeah. And so if we do that again, we go down to the intaking position. So, there we go. And so now we're gonna do what you would usually see in a match when we're shooting in the high goal. So, because we're in the pits, we don't want flying projectiles. We're just gonna block the shot.
Oh, we are gonna block. Oh, we're not.
Yeah.
So we can see.
Yeah. You can turn it low so it's a little more. So we ramp up to 4,000 RPM. And then shoot. 4,000 RPM, the note goes at around 25 miles per hour.
Are there many injuries in this class?
We have some really good safety protocols. So we have safety glasses on. We made sure we didn't have flying projectiles. So actually, we're pretty safe. But in the case that we need it, we have any first aid kit stuff. But yeah.
Number 5, starting off with red, we've got 8567. Sponsored by Wellesley Public High School, Schneider Electric. Analyze Innovate Transport Company from Wellesley High School in Wellesley Hills, Massachusetts. It's Team Ultraviolet. 3, 2, 1, crescendo! Qualification match number 5 is underway. Behind period neutrons. Lots of quick shots up into that speaker. Make their way across the field, trying to pick up another from the center. Meanwhile, Morpheus dropping off a note into that amp. 29-4 to start things off. Neutrons right out of the gate. They're going to drop off another note into that amp, see if they can get that speaker amped up. Row handlers looking to come to life. Ultraviolet as well, lining themselves up on that subwoofer, trying to get one of those notes into the right speaker. Oh, it's so close, bounces around but bounces out. Meanwhile, our rope handlers, they're going to drop a note off into the amp. A long shot from TJ Squared. Team Ultraviolet does get a note into that speaker and we'll line up another one. TJ Squared shooting from halfway across the field, trying to find that speaker. Neutrons meanwhile taking the closer shots, and that's an amped out speaker on the blue side. Those notes are worth even more points. As many as they can score in that amount of time when the amp is activated. Panthers looking to drop off another note into that amp. It's TJ Squared now making their way back to the source. Morpheus going to join them. Another mid-court shot, big collision. They vie for control of their sources, trying to get these notes. Morpheus sending another shot into the speaker. Neutrons line one up, fling one in. They've got a couple notes off on the side as well. TJ Squared basically assisting Neutrons, passing these notes off to them so they can pick them up and get them into the speaker. 67-12, cooperation bonus has been activated. Blue Alliance has well surpassed the 15 notes required for the melody ranking point. Neutrons fly right on under the red stage, make their way back over to the blue wing. 23 seconds to go. Neutrons getting the missiles set up to get on stage. Guitar riff is there. They're carrying a note. Neutron into the trap. As they get on stage to the spotlight. Oh, so close. See if they can get that bonus points. For Neutron to the right. Just off the mark. TJ Squared now working to get involved. Trying to get on to the stage. Can they flash themselves in time? Just missing as time runs out.